Form 1 that we've already talked about was vertex form. And that was y equals ax minus p squared plus q. And a equaled the stretch. P equaled the x, the vertex x. Q equaled the vertex y. And there was something special about that. It had to be opposite. Yeah? Yeah. Now, this, you can quite plainly see, is not written in vertex form. And yet, because it has a 2 there, we know that it will make a parabola, right? So this is standard form. Now, we have done lots of practice with that equation, not graphing it, just doing stuff with it, right? What are the 2 options that we have for dealing with a quadratic in that form? What is one thing we could do? If this wasn't pre-calc 11 and I just showed you that, what is one thing you would do? Rhea, pardon me? You could do a T-chart. Is that what you said? T-chart? Excellent. Yes, we could do a T-chart. But pretend we're not in pre-calc 11. We're not graphing. What would you do if I wrote that on a piece of paper? What's the first thing you would try to do if I said, do something with that? But we're not in pre-calc 11 yet. So what would you have done? If this was grade 10, what would you do with that? You try to factor it, right? Does it factor? Are there factors of 4 that add to 6? No. So factoring's out the window. Now we come to grade 11. And Jashin says you could run it through the quadratic formula, right? And the quadratic formula gets us what piece of information from this parabola? It gets us the roots, right? Now, this will get us the roots, which would get us the x-intercepts, correct? Everybody agree? Yeah? Okay. If we do this, we end up with negative b plus or minus the root of b squared minus 4ac over 2a. Agreed? Right? And what would that be? It would be 6 plus or minus the root of 36 minus 4 times 4 minus 4 times 4 times 1 over 2. Yeah? Right? Which would get us 6 plus or minus the root of 20 over 2. Which would get us 6 plus or minus 2 root 5 over 2, which would get us 3 plus or minus root 5. Does everyone agree? Is that useful for helping us graph if we don't have our calculators? No, why not? Why doesn't that help us graph this? What about that is bleh? It's a math answer, isn't it? That's hard to put on a graph because what is the square root of 5? Right now, quick. What? Quick. No calculators. What is it? Right? Nobody knows, yeah? So we're kind of screwed, right? We know that we can use the quadratic formula and that's going to give us the roots, but those roots aren't really helpful to us, are they? If I say graph this, that's a pain. Everybody cool? Everyone agrees? Okay, what's the other thing that we can do with standard form? The one that none of you like to do. Complete the square. Let's do that. Y equals x squared minus 6x plus 4. I don't like that 4 there, right? So y minus 4 equals x squared minus 6x. What's half of 6? 3 squared? 9 plus 9. How much did I add to this side? So how much do I add to this side? Plus 9. Now I have y plus 5 equals x minus 3 squared. Yes? Everybody cool? What should I do with that 5? Move it. X minus 3 squared minus 5. Does that look like something I can now graph super easily? How would I graph the highlighted green one? Where would I go? The vertex is 1, 2, 3, 1, 2, 3, 4, 5. And now how would I graph it? Up 1 over 1, and then reflected on the other side, and then up 2 over 2 up 4, reflected on the other side. So, which one helps me graph it better? Completing the square. What do we take away from this? Complete the square gives us vertex form. Now, we have come across many in our completing the square practices that are yucky, right? This one was not a yucky one. This was so easy we did it in our head in 2 seconds, right? But like all math, as hopefully you have noticed as you've gone further and further along, there's always more than one way to do every problem. And learning one way to do every problem is not useful, right? So let's do this second one. I could run that through the quadratic formula. And that would give me the roots, yes? If I run that through the quadratic formula, it is not going to give me pretty roots, right? So I could, and it would take me a minute, and we'd get non-pretty roots. Or, since we're trying to graph, I could also try to run it through completing the square, and then I'd be able to graph it right away. So, here, I don't like that 11, right? So I'm going to move it. And I'm going to get y, forgot the minus 11. Minus 11 equals 2x squared plus 8x. What don't I like on the right now? I don't like the 2. So y minus 11 equals 2x squared plus 4x. Now what do I do with the 4? Divide by 2 and square to get what? 4. How much should I add to the right side? No. 8. Why is it 8, Joshin? Because there's a 2 there. So how much do I add to the left side? 8 plus 8 because, and I'll use a highlight, 4 and 2. Yeah? So I get y minus 3 equals 2x plus 2 squared. What don't I like about that 3? Equals 2x plus 2 squared plus 3. Now can I graph that in my sleep in 2 seconds? I can, can't I? What is it? Where do I go? What's my vertex? -2, 3. 1, 2, 1, 2, 3. When I go right 1, how far up do I go? 2. Why is it 2? Because I've got an a value. So I'm going to go right 1 up 2. So that is going to be negative 1, 5. And over here, will it have the same x or the same y value? Y value. So it will be negative 3, 5. Everybody good? Now, if I'd only done the quadratic formula, which everybody would want to do, would I even get roots? No. So all it would tell me was that it's a parabola floating above or below the x-axis. Doesn't actually help me graph it. Everybody cool? Okay, now, I want to show you something else. There's something really neat that happens here. Well, I think it's neat, but I'm a math nerd. Remember the quadratic formula, negative b plus or minus the root of b squared minus 4ac over 2a, right? Now, we already know that this can be very helpful, right? What do we call that? Starts with a D, ends with a T, has, you reckon my joke, discriminant in the middle of it. Yes, it is discriminant. We know that can be helpful, right? Well, so can this. Through experimentation, negative b over 2a. Run that on this equation. What would be going in for negative b? It would be what? Negative 8. 2, what's a? 2. What's negative 8 over 4? You get the x value if you use just that part of the quadratic formula. So there's a couple of new things we can get out of this, right? 1, we can complete the square. When would we complete the square? What conditions make completing the square the way we want to go about this? What has to be there for us to be happy? I mean, you guys are never happy completing the square, but you know what I mean. When would you complete the square? Right. You would complete the square when b is even and a can be made to equal 1. If you can do that, completing the square is great, right? And what do we get when we complete the square? All of that gives us the vertex form. And makes it easy to graph, yeah? Everyone agree? Okay, what if this isn't true? Well then, if this is a no-go, then we've got a second thing we can do. The vertex x value, equals negative b over 2a. Everyone agrees? I just proved it to you, right? Negative b over 2a will give me what? It gives me an x value, yes? How does that x value help me? Where can it go? Where can I put any value I get for x? Not the x-axis. Anywhere there's an x in the equation, I can put that, can't I? Is that an x? Is that an x? So once I put those in, that's going to help me find y, isn't it? So an x value for subbing back in. Now you will notice we've talked about x. We've talked about b. We've talked about a. Once we have x, we can find y. What's the only thing missing here? What haven't we talked about? C. Nice job, Hallie. Do we know some stuff about C? We know some stuff about C. Yeah, we do. Okay, let me ask you this. Is there always a root to a quadratic formula? No, we know that from the discriminant, right? So there's not always an x-intercept, is there? What about y-intercepts? There's always a y-intercept, isn't there? And every single y-intercept in the universe has what coordinates? 0, y. Agreed? So I'm just going to slide over here. You don't need to write this down. I just want to remind you of this. You all remember this from the 10th grade. What are the coordinates of that y-intercept? 0, negative y. Right? Everyone agrees? Okay. What are the coordinates of that y-intercept? 0, positive y. Everybody cool? What are the coordinates of that y-intercept? 0, negative y. Agreed? What is the same in all three of those? 0. 0 represents what letter? X, correct? What do you see there and there? X's, right? Well, the third thing this tells us, if x equals 0, then I get a y-intercept, don't I? We know that from in a straight line, right? When x is 0, you must have the y-intercept. So y equals ax squared plus bx plus c. What is going to happen to ax squared when x is 0? What's this value going to be? It's going to cancel it out. What's going to happen there? So I'm going to be left with y equals c, aren't I? If y equals c, y, then what is the y-intercept? C. Is everybody cool? Have we learned anything new about parabolas? No, we know they have a y-intercept. We know y-intercepts exist where x equals 0. Right? The only thing you've learned that's new is this, and this isn't new math. This is just a shortcut that other guys figured out from messing around with parabolas. Everybody cool with this page? All right, let's apply it. Oh, look, it's all right there for you. Ha ha ha, I didn't need to make you write it down. But I did. You know why? Because when you write stuff down, you remember it. There's everything I just said. Now, you will notice something new is happening here. That notation. All of you should remember it from grade 10. F of x is our output, which means it is a y value. The only reason we go to f of x is because we're not always using x's and y's. Everybody cool? We all remember how to read that, right? So those two on the previous page that I had y equaled x squared plus 6x minus 4. The only difference is that y is now being written in function notation. All of you did that in grade 10, or at least you should have. 27 of you did because you were in here with me. Cool? So will this change any of our planning, any of our work? No. Now I have told you I want you to sketch the graph. If I have to sketch the graph, then quadratic formula is not my best friend, is it? So which is why I have reminded you, you should put it in vertex form. But we can get some information before we put it in vertex form, because we already know that, don't we? And if we already know the y-intercept, and do we know if it's a happy or a sad parabola when it's in this form? We know that too, right? Because A would be right there, yeah? And positive A is happy, negative A is sad. So if I know the y-intercept and I know if it's positive or negative, then I'm already a long way to knowing what my graph is going to look like. Yes? If I have a positive y-intercept and it's a happy parabola, I know it's going to look like that or that, right? If it's negative, I know it's got to look like that. So it's a good thing to have, stashed away in our heads. So let's take a look at A right now. Please notice that all of these, well, A, C, and D are pretty easy because they're even, right? B is going to be a problem. We're going to leave B for last. So what do I know right away about A before I even start working? I know something right now about the graph. What do I know? It's happy. It's that kind of parabola. And what else do I know? I know one other thing right away. Right. The y-intercept equals -6. Yeah? Okay. Let's go. What should I change f of x to so I can work with this easily? Y equals x squared plus 10x minus 6. Yeah? Am I missing something out there? Like a drone flyby? No? I mean, it's April in the lower mainland. Oh my God, it's cloudy. It's not raining. Are we covered? Okay. But it's not. Rhea, it's not. It was raining earlier.
I don't think it's raining.
And then sketch the graph. Well, we're going to be at -5, -31. And I know I've got to go through -6, correct? Everyone agree? Okay. So I went 5 this way and up to -6. Yes? Okay. So that means I got to go 5 this way and up to where? -6. So what would that point right there be? -10, -6. And there's my graph. Easy peasy, yeah? Okay. B. Why don't I like B? Because B is odd. Now, could we do this? We are more than capable of writing 5 over 2 and squaring it, right? That's 25 over 4. Then we add it to both sides, and we could do it, right? Do you want to? I don't either. So I've been gracious enough to give you another tool to deal with these when you're kind of stuck, right? Which is, B is yucky, B is odd, so what am I going to use? I'm going to use Vx equals negative B over 2a. So my vertex x value equals what? What does my vertex x value equal? Negative 5? Negative 5 is 5 over 2. Now, please notice, damn, son, that's an x value, right? I still got to put a fraction in here and multiply it out, don't I? So you still got to be able to do it anyway. That's what I wanted to show you. You see that, and you're like, damn it, I'm not completing the square. But you get to get away from fractions? Not likely. So you're still screwed, right? Everybody with me? So now, where can that go? That could go there and there. And that would give me a y value, and I would have a vertex, yes? And once I had a vertex and a y-intercept, I could graph it, right? No. What? Which one? Yeah, I'm going to do that right now. Because it's going to end up giving us the same thing as if we completed the square. Okay? So, this is an x value. I don't have a y value, right? My common denominator is 4. Sorry, not plus, idiot. So is that a y or an x value? That's a y value. Do I now know my vertex? Do I have both components of the vertex? What are they? 5 over 2 and 13 over 4. So now I could graph it. Except I would go out to 5 over 2 and up to 13 over 4. And I know it's a happy parabola, and I know it's got an intercept of 2. So 13 over 4 is 3 and a bit, right? Right? And 5 over 2 is 2 and a bit. So I go out to 2.5, 2.5, and up to 3 1/4. And I do my graph. Everybody good? Now, if I completed the square, I'd find the same thing. I would like for you people, let's do C and D together. So, what do we know about C? I'm going to rewrite it down here so I can see it. 3x minus 6x plus 7. Is this a decent candidate for completing the square? Yay or nay? Yeah, why? Why is it a good candidate to complete the square? because this is even, and because I can factor out that 3, yes? So it's going to be y minus 7 equals 3x squared minus 2x, right? Now we complete the square. Half of that is what? 1 squared is 1. How much did I add to the right side? No. 3. So how much do I add to the left one? 3 and 1. I added 3, so I add 3. Y minus 4 equals 3. X minus 1 squared. Y equals 3. X minus 1 squared plus 4. Now you graph it with no help from me. And I want to know 5 points from it. You can tell me 2 of the points on this graph without actually doing anything. Where should I start? Vertex, which is at what? 1 and up 1, 2, 3, 4. Does everyone agree? Yeah? Okay. When I move 1 to the right, how far up will I go? 3. So what is that point? If this is 1, 4, what is that point? 2, 7. What is automatically over here at 1 to the left? What's its y value going to be? Its y value will be 7. And what's its x value? 0. Can I use that to check if I did it right? Sure I can. Because what's my y-intercept up here? 7. Was my y-intercept 7? So I must be graphing it correctly. But Mr. Myers is a pain in my butt. He wants 5 points. So when I go over 2, how far up should I go? Why is it 12? Because it's stretch of 3. So when I go over to 3, I got to go up 12. So what is this point going to be? 3, 16. And what is this point over here going to be? You know its y value is what? 16. And you know you're just 2 away from the middle, so it's -1. And there's your 5 points. Does everybody get it? Great. Do the next one all by yourselves. No help from your favoriteest math teacher ever. I know I'm not, but that's okay. Some of you, I have to be your favoriteest math teacher ever because I've been your only math teacher in high school. It's like saying you're the worst brother I've ever had, but you're automatically also the only brother, so you're automatically also the best.
I had 2 brothers.
Yes, that is true. That is true. I have one of each, so my brother is both the best and worst brother I could ever have. My sister is also the best and worst sister. So see, your sister is both the best and worst sister you could ever have. Huh? Everyone is good, yes? Once again, I remind you, what have we really brought to this party? We got to substitute in X's and Y's. When did we learn that? Grade 8 and 9, right? I got to put something on a graph that is made up of what? X's and Y's. I got to follow a pattern. A week ago, we learned that pattern using what technology? A T-chart from grade 7. Over 1, up 1. Over 2, up 4. Over 3, up 9. Right? We're not bringing anything new to this. We're just putting every single thing we've ever learned together. Right? Now, please look. Every single one until 13 and 14 are easily completing the square. Right? When you get to 13 and 14, you may either use Vx equals negative b over 2a or complete the square. Now, ladies and gentlemen, this is an X block week. Please notice how many of all those things that you've ever known go into one question now. It's a lot, right? Again, it's not particularly difficult, but it is definitely complex. Yes? Complex, but not particularly complicated. So, if you need some extra practice this week, it would be a good idea to sign up for X Block. Now look, I have a quiz coming. All right? We probably won't get to that quiz until X Block. Okay? But it would actually be a really... What kind of day is Thursday? Do we know? A, B, C, D. Oh, terrific. So you people are here, and then it's X Block. Damn, son, that's a pain. Ah, well, we'll figure it out later. Everybody good? Now, wait. Wait. Sketch the graph of each function. Listen, please. When I give you a test on this, and I say sketch the graph of the function, at least half of you are going to do this. You're going to find the vertex properly, and then you're going to just do that. Tell me there it's sketched. Is that okay? Of course not, right? If you're going to do the work, and you're trying to prove to me you understand what's going on, what must I add to that? I gotta see some points. Okay? I gotta see some points. If you show me the first two on either side, does that cover for me as your marker? Does that show me that you know what the stretch factor is? What A is? Yes, because if you show me 2, I know you know the stretch, right? If the y-intercept is supposed to be positive and you've drawn it this way, can I give you full credit? No, even if you've got the vertex right. Everybody cool? So I need at least the vertex, and it would be nice to have the second point, the second 2 points away, or the vertex and the y-intercept would be helpful too. But use your brains. Everybody cool? Remember, the whole point of doing work is to show you understand the concept. If you just draw me that, all that tells me is you know the difference between a happy and a sad parabola. That tells me you know one concept. Everybody good? So use your brains. I'm done. So you should all be able to do these on your own. You should be able to get them done before tomorrow's class, because class goes for another 35 minutes. And there's only 14 questions there. Everything I just said, it's 5 times 5 to get 25 over 2. Not 5 times 2 to get 10 over 2, you idiot. Thank you, Jorik, for catching that, or for needing to read it. Hey, weather report, it's not raining. It's not raining. Hey, it's not raining. You ever see the biggest hailstone that ever fell? Like that big. Piece of ice falling out of the sky like that big. Oh, it kills you. Hail is killing people. You know, that's what you're just walking along and ice smacks you in the head, you're dead. I don't know what you can also be hit in the head with falling toilet stuff.
Go for look surface now. Because if you actually had a
No, I think they know that it can be fixed. Yeah, there's an extra holding tank. Yeah. It's like a double hole.
Yeah, and then they have that.
When you crap in a plane, you ever been to the house by the back of a bus? You ever been on a bus anywhere? It sucks. It sucks it down to a tank. But the problem is when you're up in the atmosphere, metal shrinks and expands. It gets way colder. So on the ground, the metal is solid. Right? When it goes up, it shrinks, and that moves the seals. So very easy, the blue stuff can get out on the outside of the plane, and it's like a glacier. Every time someone flushes a little bit more, like a millimeter at a time, and it builds up on the outside of the plane, and sometimes it falls and hits the ground. But now there's two tanks. So the inside tank is kept pressurized.
No, it doesn't. It doesn't help you so.
Yeah. It's just blue. Which is kind of grody. Sky is falling, yes.
I don't think here is Chipotle.
Claire's original death sauce was Chipotle.
Chipotle.
Would you like to try? This stuff comes with a little keychain that's a skull. Son of a. It's cold. Physics, where'd she go? Damn. Oh, where's Van Damage? We can show some physics. Jambalaya. Hey, look, I found my purple water bottle. I know you were all worried about it. In the staff room. Sure. Fill my water bottle up. So walk 5 steps that way, then walk 5 steps this way, drop this off, and then finish your walk. Don't spit in it. I am reffing 2 rugby games today. I don't understand why I'm in such high demand when everybody hates the way I ref. I don't get it. They don't. I'm just joking. So my wife was watching Love It or List It Vancouver on Sunday, and I'm looking at the houses they're looking at, and I'm like, man, that doesn't look like any part of Vancouver I know of. I've lived here my whole life. That doesn't look like no Port Moody. That doesn't look like no Chilliwack. That doesn't look like nothing. You know where they were? Kelowna. And they're calling it Love It or List It Vancouver. Well, they have to, because really, why would you do that show in Vancouver? You live in a broken down piece of crap house. $3 million.
Well, I think maybe because you would be more excited to watch Love It or List It Vancouver versus Love It or List It Kelowna.
Mm-hmm.
Because a nicer region, you know, one of the film capitals of the world, and says, where? How's it going?
There's the first two if you would like to check your work. My sketched graph is not so hot on the second one. This other point should be further over here. Jashin, you're a good student. You don't piss around. If you don't feel well, go.
I have a project.
Oh, okay. Because I went, oh, sorry, it's 013. Because I had to go up 16. Thank you, David. You know when you get to the bottom of a plate of food, you're like, damn, that was so good, I wish I wasn't at the bottom. Right now, yeah. And this was the last of this particular meal. It is. Because I don't use recipes, every time I make the same dish, it's always slightly different. This was a particularly kick-ass version of this. It takes all the fun out of it. I'm like the Swedish chef. Borgie, 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 borgie.
See, what I do is, if I were to do that, every time I make a nut, write down the recipe exactly.
Yo. Of course.